Hello, and welcome to Algebra Unit 2, Concepts 3 and 4, Lesson 2. Today, our objective is that scholars will understand and apply geometric sequences to real-world scenarios. Remember that you should be completing your notes as we go. So the first question is, are geometric sequences functions? And the simple answer is yes. The definition of a function is that each input has exactly one output. So geometric sequences are functions. Every input has an output. In order to make them look more like functions, you can replace a sub n with f of x, and you can replace n with x. So instead of writing a sub n equals, you can write f of x equals. And instead of anywhere you would have had the n, you're going to put the x. So a geometric sequence function would look like f of x equals a sub 1, whatever your first term is, times your common ratio raised to the x minus 1 power. So when can we use geometric sequences? Geometric sequences do have a few specific things we need to look at. The input, which is the number of your term for it, is all positive integers. So what do I mean when I say positive integers? That means it could be numbers like 1, 2, 3, 4. You can't have numbers like -7 or 2.8 or even 0. So those are your inputs because they have to be the number of the term. We have a first term, second term, third term, fourth term, etc. The output is the actual term. And it can be any real number, positive or negative. So for this sequence, 2, 4, 8, 16, 32, the input of 1, or term 1, gives us an output of 2. The first term is 2. Or we could say f of 1 equals 2. Same thing. Input of 2, our second term, this is input 1, input 2, gives us an output of 4. We could also write that as f of 2 equals 4 in function notation. Finally, an input of 5 would give us an output of 32. If we look at our terms, we have term 1, term 2, term 3, term 4, term 5. So term 5, f of 5, would give us an output of 32. So what are the requirements? When can we use geometric sequences to model? So the big thing is the inputs must meet our requirements. That means they are only positive integers. That's it. All of our inputs must be positive integers. So what types of situations might that be? The situations, things like a computer virus. Something that sends emails once a day or once an hour. And we think about that, for a computer virus, we have an initial value. It'd be how many computers were originally infected. And then we have a common ratio, how many emails each one sends. And we can use that to write our function, f of x equals our initial value, whatever number of computers, times whatever our ratio is to the x minus 1. Okay? So remember your function notation. F of 2 means tell me the output when the input is 2, or give me the second term in the sequence. F of 2 give me the second term in the sequence. So let's look at a few more examples. We're going to evaluate this geometric sequence. And here it is. F of x equals 4 times 2 to the x minus 1 for 3 as our input. So we have 4 times 2 to the 3 minus 1. Well, 3 minus 1 tells me it's 4 times 2 to the second power. 2 to the second power is 4, so I have 4 times 4, that means it must be 16. So 16 is my final answer there. So what is it if it's 1? We have 4 times 2 to the 1 minus 1. Well, 1 minus 1 is 0. 4 times 2 to the 0 power. Remember our exponent rules, anything to the 0 power is just 1, so that's just 4. That just means our first term is 4. Well, what about f of 0? F of 0 would be 4 times 2 to the 0 minus 1. So 0 minus 1 is negative 1. So I've got 4 times 2 to the negative 1, which is 4 times 1/2, which would be 2. So I can evaluate it, but stop for a second. Can there be an f of 0? 0 is not a positive integer, so there is no value, no output for that input. The same thing if we have f of negative 3. These do not fit our rules. Not geometric sequence. These input has no output. These inputs have no output. Otherwise, we can say they're undefined in this case. But you can't give me an answer. These inputs have no output. And that's what you would say. Inputs have no output, not a valid input. Okay? So, good luck on your classwork and then on your mastery check. If you have any questions, email me.